Apes are the most intelligent group of creatures on the planet. This is a pretty well-known fact, but the story of how they evolved gets far less attention. However, their journey is actually one of the most incredible in the history of life on Earth. In just 20 million years, the apes have evolved from small monkeys swinging around in the trees to masters of communication, socialization, and tool use. So how did they do it? Well, in this video, we'll go through both the fossil record and genetics to trace back the evolutionary story of the apes. During the early Miocene, approximately 22 million years ago, the Earth was in a much warmer and more humid period than today. These conditions allowed for forests to spread out across the globe, which enabled primates to expand their dominion like never before. By this time, a group known as the Catarrhines were already widespread, which suggests that they had a long history of diversification prior to the beginning of the Miocene. The Catarrhines include the Old World monkeys, apes, and any species more closely related to them than the New World monkeys, from who they diverged between 44 and 40 million years ago. And one of the most well-known Catarrhines from the Old World was Victoriopithecus, who first emerged roughly 20 million years ago. I say well known because so far 3,500 fossil specimens have been found across North and East Africa. Named after Lake Victoria, this frugivore was very similar in anatomy to many contemporary primates, with traits such as adaptations for arboreality and group living. Then, not long after, we start to see the first members of the ape lineage appear. These include Proconsul, Ranguipithecus, and Afropithecus, among others. However, for gibbons, the fossil record is much more patchy, and not long after the first ape ancestors appeared in Africa, they began to spread to the Mediterranean region of Europe. Oreopithecus is perhaps the most recent Miocene ape who lived outside of the tropics. This animal is known from 9 million year old coal beds in northern Italy, telling us that the Miocene was a really great time to be a primate. And whilst the Old World monkeys remained relatively similar to their pre-Miocene ancestors, the apes changed dramatically. Among the key differences were the complete loss of their tails, the development of broad chests, flexible shoulder joints, and a more upright posture. They also began to trend towards much larger brains, flatter faces, advanced problem-solving skills, and longer periods of parental care. As you could probably work out, it was the gibbons who were the first apes to split off from the rest. Molecular evidence indicates that this took place 16.8 million years ago, with a 95% confidence interval of between 15.9 and 17.6 million years ago. But like I mentioned earlier, our knowledge of early gibbon evolution is plagued by a lack of fossils. They are thought to have evolved where they still live today, in Southeast Asia, from an unknown ape population. However, whilst they diverged from our ancestors a very long time ago, evidence indicates that the three modern genera diverged from each other between 5 and 7 million years ago. Based on morphology, scientists believe the Siamang was the first to diverge, followed by Namascus, and with the final split being between Hylobates and Hulock. Genetics, on the other hand, suggests that the position of Siamang and Hylobates should be reversed, and is the more accepted phylogeny by scientists. In sheer numbers, gibbons are by far the most diverse kind of ape, with 20 different species spanning several different countries. 3 extinct species have been described thus far. The first of these is Bunopithecus from the Middle Pleistocene of Sichuan province. Thought to be a close relative of the Hulock gibbons, Bunopithecus is believed to have disappeared due to climatic changes at the time. The second of the extinct gibbons is Junzi imperialis, who is only known from a single skull found in a Chinese noblewoman's tomb. Dating to between 2,200 and 2,300 years ago, this fairly recent ape lived during the Warring States period. Buried alongside it were many other extinct animals, such as cranes, leopards, lynxes, and a black bear, which are all thought to have been kept as pets. The tomb, located in the hills of northwestern China, is some 1,200 kilometers from the nearest wild gibbons today. This means that they were either transported all this distance, or that they were much more widespread in the past than we thought. Unfortunately, this species along with its genus is presumed to have disappeared due to human activity, making them the first ape to be driven to extinction by people. Luckily, however, the third fossil species sheds a lot more light on their origins. The gibbon known as Yuanmaopithecus lived between 8.2 and 7.1 million years ago. Known from several fragments found in Yunnan province, its anatomy, including its 16-kilogram weight, tells us that gibbons have changed little since the Miocene. From here we see the divergence of the great apes, who went on to develop much larger sizes, ground walking, more complex social groups, and proportionally shorter limbs. Unsurprisingly, out of the living great apes, the orangutan's lineage was the first to split off, approximately 12 million years ago. This date is backed up by the fact that the earliest member of the Pongene subfamily, Sivapithecus, lived 12.2 million years ago in India. Not long after, about 11.1 million years ago, Gryphopithecus appears in Turkey, meaning that ancestral orangutans had a much wider distribution than they do today. Described in 1758, the orangutan has been known to Western science for a very long time, but it was only with DNA in 1996 that scientists found that Bornean and Sumatran orangutans were different species. Studies in 2017 revealed something even more surprising, however, finding that Sumatran orangutans from the south of Lake Toba were more closely related to Bornean orangutans than their Sumatran cousins. And soon after, it was described as yet another species, the Tapanuli orangutan. What's even more puzzling is that the Sumatran orangutan has a greater genetic diversity than the Bornean orangutan, despite having a population up to 10 times as small. Genetics also tells us that the divide between all of these species runs deep, with Bornean and Sumatran orangutans splitting between 4.9 and 2.9 million years ago. This was followed by the Tapanuli orangutan 2.4 million years ago. These evolutionary relationships make more sense when you look back in time, because during the Ice Age, sea levels were low enough for the apes to simply cross over by land. In fact, this is how they got to the Sunda Islands. The Pongene subfamily's fossil record is particularly rich in species too, including Indopithecus, who lived in India between 9.2 and 8.6 million years ago, Koratpithecus from between 5 and 7 million years ago, who is actually believed to be the closest relative of the orangutans, Lufengpithecus, who hung on in China and Thailand until 2 million years ago, and of course the most impressive of all, Gigantopithecus, the largest primate ever, inhabited China as recently as 300,000 years ago. For these animals, habitat changes during the late Pleistocene occurred too fast for them to adapt, restricting them to just the tropical forest of Indonesia. After the split from the orangutans, the ape family tree entered the Homininae family. These species became much less arboreal, developed more powerful limbs, darker hair, increased sociality, and began to turn away from fruits to stems and leaves. And the first lineage to diverge from the Homininae were the gorillas. The earliest fossil species thought to be ancestral to this lineage is Nyctalopithecus, who is known from 9.9 million year old fossils from Kenya. Genetics tell us that the split between us and the gorillas took place between 8 and 10 million years ago. But for gorillas, the fossil record is unfortunately limited, as the acidic soils of rainforest almost always dissolve bones before they fossilize. On an interesting side note, the gorilla gets its name from Hanno the Navigator, an ancient Carthaginian explorer. Whilst on an expedition to what is now the coast of Sierra Leone, around 500 BC, he came across a creature never documented before, describing them as savage people, the greater part of whom were women, whose bodies were hairy, and who are interpreters called gorillae. It's not certain whether these were gorillas, which today don't inhabit the region. However, during the 1800s, gorillas were documented as far as Liberia. Strangely enough, despite thinking they were people, he brought several of their skins back to Carthage, though unfortunately they were destroyed during the Punic Wars. However, we are still discovering new things about them today. In fact, it was only recently that it was discovered gorillas actually represent two different species, both of whom can be further divided into two subspecies. It is believed that the two species diverged after becoming separated during the Ice Age, when forests became fragmented as the region became much drier. Genetics suggest that this split happened around 261,000 years ago, which coincides with the third most recent glacial period. After the gorillas, we are left with just one line, the hominins. Members of this group continue to develop larger brains, the ability to stand on two legs, warfare, an omnivorous diet, and most importantly, complex language. The hominins went on to split into the two groups that are still around today, the chimps and humans. Interestingly, despite the big evolutionary changes, this took place not too long after the gorillas diverged, somewhere between 7 and 9 million years ago. Like gorillas, the chimps' habitat means few fossils of their ancestors have been preserved. In 1933, a new member of the pangenus, the one that includes chimps, was identified, the bonobo, distinguished by a smaller size, a black face, and a more altruistic nature. Fossils from the pangenus were first discovered in Kenya in 2005, showing that they overlapped with early humans in the Middle Pleistocene. The relationship between bonobos and chimps may also be more distant than you think, because they split roughly 2 million years ago. This is likely because the spread of open habitats meant that they could no longer migrate around the Congo River. Breeding between bonobos and ancestors of eastern and central chimpanzees occurred sometime between 550 and 200,000 years ago. Presumably, a warmer period led to greater forest cover. Whilst the chimps' lineage continued to remain in the forest, some hominins ventured out into the grasslands of the Serengeti and the Sahel. There they would have come across a very different set of plants and animals, including hyenas, antelope, and other savanna specialists. This coincided with when the rainforest contracted roughly 8 million years ago, giving them no choice but to adapt or die. The earliest identified species in this lineage is Sahelanthropus from 7 million years ago in Chad. Only known from a single skull, Sahelanthropus was followed by a Roran from Kenya 1 million years later, known from 5 highly fragmented individuals. The next to appear was Ardipithecus caraba from Ethiopia's Afar Depression 5.77 million years ago. Following Ardipithecus was the infamous Australopithecus from around 4.3 million years ago. Known from over 100 fossil individuals from Ethiopia and Kenya, around 2.8 million years ago they evolved into Homo, the genus that we are a part of. Thanks for watching. If you want to stay up to date on all things paleontology, make sure to subscribe so you don't miss my next video.